Logarithm part 3. Now, let me discuss something related to rules. Len u, where u is positive, find the domain of len x plus 3, right? These are examples. Directly, x plus 3 is positive. This means that x is greater than minus 3. So the domain is from minus 3, open at minus 3, up to plus infinity. That makes the u positive. Same here. X squared minus 3x plus 2 is positive. This means that x minus 2 into x minus 1, we factorize, right? Greater than 0, or we find it by delta discriminant, quadratic, because it is a quadratic equation. Since a is 1, which is the coefficient of x squared, is positive, and we need it positive, so it takes the sign of a, which is positive, outside the roots, so where x is less than the smaller one or x is greater than the largest one. So the domain is from negative infinity to 1, open at 1, union from 2 to plus infinity. Any value we choose either here or here, in this interval or in that interval, that makes x squared minus 3x plus 2 positive, and we need to do that. Same for here. Len 3 minus x over x plus 4. So we have two values. X minus 3 minus x equals 0 gives us x equal 3, and x plus 4 equals 0 gives us x equal minus 4, right? Minus x times x is negative, so it's negative outside, positive inside, or we do the the table of sign, right? From minus infinity up to plus infinity. We have minus 4, we have 3, and we need to have the sign of 3 minus x over x plus 4 to be positive, right? One of the factors is 3 minus x, the other factor is x plus 4. 3 minus x equals 0 when x equals 3. Same sign as a, which is minus 1x, to the right, opposite to the left. 0, same sign as a, which is plus 1, to the right, opposite to the left. Minus, plus, minus. This one in the numerator could be 0. This one, since it's in the denominator, couldn't be 0. We need it to be positive, so it's between. So the domain is from minus 4 to 3, right? Between minus 4 and 3. For sure, open at minus 4 and open at 3, because we don't have, we need the 3 minus x over x plus 4 to be just positive, right? Just positive. All right. And other rule is we need to know that len 1 is equal to 0. Len e is equal to 1, where e is 2.718. It's more than that. It's 2.718 to 8 something. It's a rational number. It never ends. And it is value between 2.718 and 2.719 actually. And its len is equal to 1. So directly when we have len 1, we know we should put 0. When we have len e, we should put equal to 1. What else? This is very important rule. If we have len a times b, the answer will be len a plus len b. For sure, where both a and b are positive, because we're using them inside len. Len a divided by b, it's len a minus len b. Len a to the power n, it's n multiplied with len a. Let's do this example. Find len 8 in terms of len 2 and len 3 and len 6, right? Len 8. Len 8 is equal simply len, let's change it to base 3, to base 2, to the power 3, because we need it just in terms of len 2, okay, and len 3, but here we don't have len 3. Okay, this, we can apply this rule, which is len a to the power n, so the answer is going to be 3 len 2. Len x to the power n is x, len is to the power n is n len x. So here we have 3 len 2. Okay, and len 6 is equal to len simply 2 times 3. And len a times b is equal to len a plus len b. So this one is equal to len 2 plus len 3. I used len 2 and len 3. Len 1 over a is minus len a. And why is that? Because it's equal simply, if we're using this property part 4, or this rule part 4, len a over b, so it's going to be len 1 minus len a, because len a over b is len a minus len b. So len 1, which is a here in the numerator, minus len in the denominator, right? Len 1, we said it's equal to 0, so what left is minus len a. This is the answer. We can take it, or in another way. Ln 1 over a, simply it's ln a to the power minus 1, reciprocal of a, which is minus 1 multiplied with ln a, right? It depends on the formula that says ln x to the power ln a to the power n, right? It's n ln a. Ln a to the power minus 1, it's minus 1 ln a, means minus ln a as well, right? Those are very important properties before we start. Let's start some exercises. Find the domain of definition of the following. I will not do all of them, but I will leave them for you. And if you have any question, you can just send me your just email, and I will solve them. Or any other questions other than these, also I will solve them for you. F of x equal ln x plus ln into 1 plus x, right? First, we have here x inside, so we say that x is positive, right? And here we have 1 plus x, so we say that 1 plus x should be positive. This means x should be greater than minus 1. We need x to be greater than minus 1, and we need it also to be greater than 0, so they meet at x greater than 0. So the domain in this case of function f is just from 0 to plus infinity, and once we say from 0 to plus infinity, this means we said it's greater than minus 1. We can't say from minus 1 to plus infinity because it will not be greater than 0, right? Otherwise, we draw the line, simultaneous line, that I did in the first video. Simultaneous table. This one differs, right? This one is x times ln 1 plus x squared. It's g of x, right, is equal to x ln 1 plus x to the power 2. First, x, we don't have a problem in that because it's just polynomial function outside, right? What we have here is this number inside, and it should be positive. But it is positive. It will be positive whatever x. Why? Because x squared is positive or equal to 0. Added to it 1, it will be greater or equal to 1, right? Added 1 to both sides. So this number is strictly positive, cannot be equal to 0. X squared plus 1 is strictly positive, cannot be equal to 0. So whatever x, we don't have any problem. We just change, substitute instead of x any value. It gives me positive value over here. So domain here of function g, it's all set r, etc. You can try h of x and g of x, and you can tell me. Let me do just h of x. Okay. Let me do again h of just h of x, because I will not start the other number except in the other video. Okay, let me do here this one, x into 1 plus x. All right, two values, x into 1 plus x should be, since both inside these two factors inside the length, so it will be positive. This means we have two values. Okay, if you don't like to do it as same sign as a outside, opposite inside, you can just, since it's factorized already, just insert them over here. Taking x equals 0, so we have 0. Taking 1 plus x equals 0, so have minus 1 in order. And one of the factors is x, the other is 1 plus x, and the product is x into 1 plus x, right? X equals 0 here, same sign as a, which is positive to the right, opposite to the left. Same sign as a to the right, opposite to the left, which is positive. Multiply them. Plus times plus is plus. Minus times plus is minus, minus times minus is plus. Great. We needed to have this as positive. So where it is positive, it's either here or here. So the domain of definition is simply of function h, right? Is simply when x belongs to which interval? From minus infinity up to minus 1 cannot be equal to minus 1 because it will be equal to 0. Union from 0 to plus infinity, right? This is the domain. You can continue your work. All right, write in terms of ln x, ln 2, in terms of ln 2. Okay, let me start. We still have just some seconds. Ln 2, ln radical 2. It's ln 2 to the power half, right? It's radical, so it's power half. So the answer is ln x power n. It's n ln x, so it's half ln 2. This is in terms of ln 2. And this one is nice. 512. It's ln 2 to the power, how much? 2 to the power 9, right? 2 power 9. If you multiply 2 multiplied by itself 9 times, it gives us ln 2 to the power 9. So it's 9 ln 2. And continue other video.